Thank you for joining me. What we're going to do now is we're going to determine if the series, the sum from 2 to infinity of negative 1 to the k over k natural log of k, conditionally converges, absolutely converges, or diverges. And so as we do this, we're going to be working through our divergence test decision tree. And so I have a link to that in the description below if you'd like to follow along. So the first question posed to us is the limit of the terms equal to 0? So that is the limit as k goes towards infinity of negative 1 to the k over k natural log of k equal to 0. And so as we look at this, I just want to think about what happens here is that, well, negative 1 to the k is going to alternate between negative 1 and positive 1, but it's going to be either 1 or negative 1. On the bottom, what we're going to get is that k is going to get large, natural log of k is going to get large. And so what we end up with is either positive or negative 1 over an arbitrarily large number. And so we do indeed get that this is going to get arbitrarily small, or that is arbitrarily close to 0. Therefore, this limit is indeed 0. The next question we're asked is, are the terms alternating? That is, do we have something in the form negative 1 to the k in the terms? And indeed we do. We have a negative 1 to the k over k natural log of k. So yes, this is an alternating series. Now the next question is going to be, do we know if the absolute value of this series converges or diverges? And since we haven't done work on that one yet, we really don't know. But we do know that because this is an alternating series and the terms tend to 0, that this series will converge. That is, it won't diverge. But we don't know if it's conditionally convergent or absolutely convergent. So what we need to do is we need to start over. We need to decide if the absolute value of the terms of the series is going to converge or diverge, and that will give us our final answer about absolutely or conditionally convergent. So again, we're going to start over and we're going to say, determine if the sum from 2 to infinity of the absolute value of the terms converges. That is, determine if the sum from 2 to infinity of 1 over k natural log of k converges or diverges. And so again, we're going to go through our divergence tree decision test. And so the first question is going to be, what are the limit of the terms? Do those go to 0? Well, notice that the absolute value is going to go to 0 since the original went to 0. So we do know, in fact, that the terms are going to tend towards 0. So we can move on to the next question, which is this an alternating series? Now, originally we did have an alternating series, but because we took the absolute value, we got rid of the possibility for an alternating series. So we're left with the new series 1 over k natural log of k. And so I want to say the first two questions we're kind of answering because we're going back and redoing this, and we can use our previous results. And so we'll pick up with the next question. Now our next question is going to be, do the terms look geometric? That is, does 1 over k natural log of k look geometric? And so if we want a geometric series, we want to say, okay, we're going to find the new terms by multiplying by something. So I can get from this term to the k plus 1 term by multiplying, but that's not exactly what's happening here. We're not just multiplying by some number to get the next term. We are just adding in k plus 1 times natural log of k plus 1. And so I would say this does not look like a geometric series. Since it didn't look geometric, our next question is going to be, does it look like a rational function? Now in this case, I would say that yeah, it does look like a rational function. It looks like we got a function over a function, and it's not quite rational because it's not just polynomials on top and bottom. We do have a natural log in there, but it does look like we have some type of rational function, so I'm going to say yes to this one. Now, in order to narrow down what type of rational function it is, we're going to say, is this of the form 1 over k to the p? That is, does it look exactly like a p series? No, it does not. It does not because it's not k to the p, it's k times natural log of k. Because I have this natural log in here, it's not exactly right. Next, we're going to decide, is this exactly rational, meaning that is this just powers of k on top and bottom? And again, it's not because we have the natural log in there, so we're going to have to say to no to this one as well. Now, because we said no to the last one, we're going to have now, can I integrate the term 1 over x natural log of x? Notice that I've changed the k's to x's because k's would be discrete, they would be just integers. But now what I'm really asking is, if I turn this into a continuous function and I use x's instead of k's, can I find an antiderivative for this function? And so now in order to answer that, we're actually going to have to try to find the antiderivative of this. And so in that process, what we're going to have to do is actually go back to the decision tree for how to integrate functions. And so I'll have a link to that below. And now we'll try to find the integral of 1 over x natural log of x. Alright, so as I'm looking at my integral decision tree, the first question is going to be, can I guess the answer? And I cannot guess the answer. If I could, I would have just written it down to begin with, so we wouldn't have to go through this process. So I'm going to move on to my next question, which is there an inside function? Now, in this case, there actually is an inside function, and so I want to be able to try to use that as much as possible. And so I'm going to say my inside function here is actually going to be natural log of x. Well, what function is that inside of? It's inside of the 1 over I function, and so that is allowed. We can say, yes, that is an inside function. I could say I is also equal to x, but that won't simplify anything. And I know if I try I equals x times natural log of x, then my derivative is going to be having to use a product rule, and I really don't think that's going to cancel out. So instead, I'm going to try natural log of x, and I hope that I can cancel the x's out. Well, if I let I be natural log of x, then di is 1 over x dx. Solving for dx, I get dx is x di. And so now I can substitute that in here, and I would get the integral of 1 over x times I times x di. And indeed, the x's will cancel, and I'll get the integral of 1 over I di. And I'm now left with a new integral, just 1 over I di. Now, for this integral, I can in fact integrate it by just guessing and checking, and this would be the natural log of the absolute value of I plus my constant of integration c. And so what I get is the natural log of the absolute value of I was natural log of x, and then plus c. And so indeed I was able to integrate 1 over x natural log of x. So now I can go back to my series problem and try to use this information. Now, as we're still trying to find if this series converges or diverges, we notice we were able to integrate this term if we turn these k's into x's to make it a continuous function. And so what I need to do now is I need to use the integral test to determine whether this converges or diverges. So what does that mean? Well, it means precisely that I'm going to integrate from 2, because I'm starting at 2 here, to infinity of 1 over x natural log of x dx. And what the integral test says is that this series will converge if and only if this integral converges. And so if I can determine if this converges or diverges, that'll give me whether this one converges or diverges. So now to find this, remember this is an improper integral. So I'm going to find the limit as b goes towards infinity of the integral from 2 to b of 1 over x natural log of x dx. And because I'm going to b, which is a constant number, before I take the limit anyway, what I get is that this is going to be, well, I can use the fundamental theorem, I can find the antiderivative, which we said was the natural log of the absolute value of natural log of x. And I'm going to evaluate from 2 to b. So what does that mean now? Is it means I plug in b and I subtract out plugging in 2. So I get the limit, and as b goes towards infinity, of natural log of the absolute value of natural log of b minus natural log of the absolute value of natural log of 2. And if I want to find this limit as b goes off towards infinity, all I'm really interested in is, do I get a number out or do I get out infinity? And so I can find what this is going to be exactly, but I'm just going to say, well, if I take the natural log of b, as b goes off towards infinity, this is going to get arbitrarily large and become infinite. If I take the natural log of an infinite number, again, it is still infinite. So I get that this would be an infinite term minus a finite term, and so we would get that this would be infinite. That is, the area under this function between 2 to infinity would be infinite. Therefore, this integral diverges. So therefore, the original series 1 over k natural log of k diverges. Alright, and so now to combine this all together, what we got was that the sum from 2 to infinity of negative 1 to the k over k natural log of k converge by the alternating series test. However, the sum of the absolute value of the term diverged by the integral test. Therefore, Our original series, the sum from 2 to infinity of negative 1 to the k over k natural log of k, will conditionally converge. Thank you for joining me today as we work through the proof of this theorem. I hope you enjoyed it, and I hope you learned something along the way. If you did, make sure to click that like button and to subscribe to the channel. There's more resources available in the description below, and also check out our other videos.